Of substation automation, that is third one. First we have discussed CT and next we have discussed VT, that is CVT. So this is second and third is the intelligent electronic devices, that is IED. Describes a range of devices that perform one or more functions of a protection, measurement, fault recording and control. So it functions like protection and measurement, fault recording and control. So you can remember PMFC. Okay, that is protection, measurement, fault recording, control. Okay, PMFC. So IED consists of a signal processing unit, a microprocessor with input and output devices. So what IED contains? It contains a signal. Okay, you can remember electronic intelligent electronic devices. So electronic devices means you will get a signal. It consists of a signal processing unit, a microprocessor with input and output devices, and a communication interface. So in order to protect or in order to measure and fault recording and control, we need a signal processing microprocessor, and communication interface is more important to control or to protect or for measurement and fault recording also. So communication interface such as EIA 232 or EIA 483. Okay, 232 or 483. Ethernet, Modbus and DNP3 are available in many IEDs. These are the communication interface, that is EIA 232 or EIA 483 serial, that is communication number. Ethernet, or they can use a Ethernet or Modbus DNP3 are available in many IEDs. So first, relay IED. Modern relay IED combine a number of different protection functions with measurement, recording and monitoring. So MRM. So relay IED, it is a combine of different protection functions, that is measurement and recording and monitoring. Measurement, recording, monitoring. So you can observe here. Okay, so this is a local measurements, production interface, communication interface. Production interface will go to the hardwired signal, trip contacts or interlocks. Communication interface, that is commands, output and input also. Okay, for communication interface, it is outgoing commands is outgoing, and it is entering remote setting or measurements is entering. Okay, so here these are the measurements, and here 50/51, 50N1, 51N, that is 50 voltage, 51 voltage. Here circuit breaker status, monitoring, events, faults, disturbance, recording. So what is the protection functions you can observe here, and here keypad inputs and manual inputs. So first, manual inputs, keypad inputs by typing or anything inputs. Okay, so this is a status, circuit breaker status we are using for the protection relay. Okay, so circuit breaker status, monitoring, events, faults, disturbance, recording. So these three are similar. Okay, so just it is a different events, faults, disturbance. So that you remember this for recording purpose. And measurements, protection interface, hardwired signal, trip contacts or interlocks. Communication interface, commands, remote setting, measurements. So protection functions is three-phase instantaneous overcurrent, three-phase instantaneous time delayed overcurrent, and three-phase voltage controlled on time delayed overcurrent, at the fault instantaneous or time delayed overcurrent. Protection functions means three-phase instantaneous overcurrent, three-phase time delayed overcurrent, three-phase voltage controlled overcurrent, and that is at the fault instantaneous or time delayed overcurrent. So you can remember ITVE. Okay, protection in protection relay IED ITVE. Okay, this is a relay IED. Here meter IED. So in meter IED, what it is a range of functions and features for measuring three-phase and single-phase parameters. So which measurements meter IED? It is a range of functions and features for measuring three-phase and single-phase parameters. Meter IED measures voltage, current, power, power factor, energy over period, maximum demand, maximum and minimum values, total harmonic distortion and harmonic components. Okay, so voltage, that is V, I, P, PF. Okay, and energy over a period, maximum demand MD, maximum and minimum values, total harmonic distortion THD. Okay, you remember this enough. Voltage, current, power factor, energy and maximum demand. So when it comes maximum, you can write maximum and minimum values also, total harmonic distortion and harmonic components. This is about the meter IED. Okay, recording IED, what it will do? Recording, separate recording IED are used to monitor and record status changes in the substation and outgoing feeders. So if any changes, okay, if any changes, then in the substation and the outgoing feeders it will record. Okay, it will be continuously monitoring. If any changes occurs, then it will record. Continuous event recording up to resolution of 1 milliseconds is available in some IEDs. Okay, continuous event recording up to 1 milliseconds is available in some IED. These records are sometimes interrogated by an expert to analyze a past event. So this simply they are not recording. It will be analyzed, interrogated by an expert to analyze a past event. This fault recorder records the pre-fault and fault values for current and voltage. So this fault recorder records the pre-fault and fault values for current and voltage. Next is a Bay controller. So in IED we have came across relay IED, meter IED and recording IED. Okay. Next is a Bay controller. These are the substation components. Okay, seat, voltage transformer, current transformer and IED. And next fourth is Bay controller. Bay controller are employed for control and monitoring of switchgear, transformer and other Bay equipment. So you can observe that is a Bay controller, relay IED which are connected to the transformer. Bay controller are employed for control and monitoring of switchgear, transformer and other equipment. So the Bay controller can vary, include circuit breaker control, switchgear interlock check, transformer tap change control, programmable automatic sequence control. Okay, that is first circuit breaker controller. Okay, circuit breaker controller, switchgear interlock check, CBC syllabus. You can remember like Bay controller CBCS. Okay, CBCS. CB means circuit breaker control. Next switchgear interlock control. Next TTCC. Okay, so after studying the central syllabus, they are going for a college. Okay, so we need a TTCC. So you can think next they are studying PUC. Okay, so PASC, PUC, like that you remember. Okay, circuit breaker control, switchgear interlock control, transformer tap change control, that is programmable automatic sequence control. The fifth one is remote terminal unit. Here the distribution SCADA system acquires data of the distribution network from the remote terminal input units. So all the details are, SCADA means it acquires the data. So how it acquires? It acquires the data from the remote terminal units. The field RTU acts as the interface between sensors in the field and the station RTU. So the field RTU acts as an interface, okay, interface between the sensors in the field and the station RTU. How it should collect the data? Okay, it should interface. Then only it can collect the data of the equipments. So there here in sensors in the field and the station RTU. The main function of the field RTU are to monitor both analog and digital sensor signals and actuator signals. So what it will do, the main function of the field RTU, it will monitor, okay, both the analog and also the digital signals and the actuator signals, that is status, okay, analog and digital signals and the actuator signals, and it will convert the analog signals coming from the sensors and actuators into digital form. Okay, it will convert analog signals to digital signals. Analog signals are coming from the sensors, okay, and actuators into digital form. Modern RTU, which are microprocessor based, are capable of performing control functions in addition to data processing and communication. So what nowadays are modern RTU, which are microprocessor based, okay, microprocessor based, are capable of performing control functions in addition to data processing and communication.